Okay, well, today we're going to start talking about naming ionic compounds and then writing their formulas as well. So, you should have gotten a copy of the handout from your substitute. The packet should have 2 pages. The first page says symbols and charges for monoatomic ions with fixed charges. And then at the bottom, it says symbols and charges for common monoatomic ions with variable charges. And then there's another page with polyatomic ions and then a flow chart. The flow chart is a compound naming flow chart for chemical formulas, kind of a synopsis of how to do naming of substances. So, uh, talk you through this a little bit. We'll do some examples as we're going through this like we have done in the past. You should be taking notes on what it is that you're seeing here for the video. So as far as ionic compound naming goes, this is definitely more complex than naming molecular substances. Ions form neutral substances when combined, and as such, they do not give any indication as to the relative numbers of each element in the compound like molecular compounds do. We're starting with ionic compounds. In the past, I've started with molecular compounds. That's why it's kind of referring to that. Overall, though, the naming of ionic compounds involves naming the cation ion, naming the anion, and then slamming them together. And that's what it amounts to. But, excuse me, because of the way in which ions are named, it doesn't tell you how many of each ion there is, so there's some work involved there. Rules for ionic compounds. Number one, metals form monoatomic ions with positive charges. We can use their group number to find this charge, and this is what we were looking at the other day when we were looking for patterns in ionic compounds. Elements in group 1 on the periodic table, group 1 being column 1, so we're talking about lithium, sodium, potassium, rubidium, cesium, francium. Hydrogen, even though it's not a metal, can also form a positive 1 ion, but for now we're talking about the metals. Group 2, beryllium, magnesium, calcium, strontium, barium, they form +2. Group 3 or group 13, instead of 3A or B, group 13. So we're talking boron, aluminum, gallium, indium. Those form +3. And then group 4 or group 14, as we talked about the other day, form +2, +4. And again, for those, we're talking only about tin and also lead. Number 2, transition metals. Transition metals are elements in groups 3 through 12. So just to differentiate here, we're talking groups 13 and 14 up here. For the transition metals, with the exceptions of cadmium, zinc, and silver, which only form +2, +2, and +1 ions, respectively, can form multiple charges. And we talked about that with tin and lead the other day. For tin and lead, in group 14, they can be tin 2 or tin 4, meaning that tin with a +2 charge or tin with a +4 charge. Well, transition metals, most of them have that behavior. And so, for instance, iron can form iron +2 or iron +3, or iron 2 ion or iron 3 ion. The nonmetals form anions, with the exception of hydrogen. Hydrogen is kind of a unique element for a variety of reasons. But hydrogen can not only form a +1 ion, it can also form a -1 ion, and we can get into that at a later time. We can use their group numbers to help us figure out their charge. So elements in group 17, as we saw the other day, we're talking fluorine and chlorine, bromine, they're -1. Elements in group 16, like oxygen and sulfur, would be -2. And then elements in group 15, like nitrogen and phosphorus, form -3. When it comes to naming these ions, there's no special rule for the name of the metal ions. If we're talking about a calcium +2 ion, it's just calcium. If it's sodium +1 ion, it's just sodium. In the naming of these things, though, the anions do change their ending. So, for instance, anions always get an IDE ending. So, for instance, oxygen, which can form a -2 charge, you change the ending of it from oxygen to be oxide. Now, question always comes up, how do you know how much of the ending of an element's name to change? What I always tell students is say the name to yourself, and if it sounds silly, it's probably wrong. I know that's a really bad rule to go by, but for instance, for oxygen, let's say we don't change anything, we just add IDE to the end, it would be oxygenide. Probably have never heard anything referred to as oxygenide before. If we take off the N, it'd be oxygeide, which also sounds funny. Oxygide, oxide, or oxide. You probably have heard things with the name oxide in it, so there we go. Other endings for IDE, nitrogen would be nitride, phosphorus, which has a big change to it, is phosphide. Fluorine is fluoride, which I'm sure you're familiar with. Chlorine is chloride. We have bromide, iodide, sulfide. Okay, IDE ending. That IDE ending, not only with the root of the element name, where you can look and see that it's a nonmetal when you look at the periodic table, but the IDE ending also signifies that that is the anion in your ionic substance. As we also talked about yesterday, some elements form polyatomic or many atom ions. There's no pattern for these. These are things that need to be learned. And this is why you have note card making materials with you today, because you're going to want to make, and well, actually required to make, flashcards that you can use for studying. I am not the hugest fan of using flashcards for reviewing things, but over the last 10 years plus that I've been teaching chemistry, in teaching how to name substances, in talking to students, working with students, flashcards and regular review with them has been the most successful method for learning the names and formulas for different polyatomic ions. So we'll talk more about your assignment here in a moment. This is a very short list of some of the ones that you need to know, but just to show formulas for them. Hydroxide, for something like sodium hydroxide, hydroxide ion is OH minus 1, nitrate is NO3 minus 1, acetate C2H3O2 minus 1. So again, as we talked about yesterday, those polyatomic ions, those are molecules, but because of how they are formed, their actual structure, they end up having an ionic charge. And so they, even though it's a molecule, it behaves as an ion because it has that electrical charge. This is why you have the handout that you have. We have more examples of the different names and charges for different elements. Again, for these ones with fixed charges, you can often figure out what their charges are by looking at what group or column they are in on the periodic table. So for instance, here, the hydrogen, which is +1, lithium +1, sodium +1, potassium +1, they're all in group 1. Magnesium, calcium, strontium, they're all +2 because they're in group 2. We have aluminum, which is +3 because it's in group 13. We have the negatively charged ones. We talked about what groups that they're in, but notice that the endings of their names have changed to IDE. This set of elements, I would not say that you need to make flashcards for. The only ones that I would suggest that you do are these three here, the silver, zinc, cadmium. Those are the transition metals. With fixed charges. I would not mess around with flashcards for any of the other ones listed on this page, but you might want to make them for those so that you get used to, all right, that's a transition metal, but it's silver, zinc, or cadmium. They have a fixed charge. What is it? Okay. Here we have a list of transition metals and also lead and tin from group 14 that have different charges. The ones that I have highlighted here, and they're highlighted on your handout as well, I would make flashcards for these ones. I know it says that it's copper 1 and copper 2, and we already talked about how that 1 and 2 tells us what the charge is. But getting used to seeing copper 1, copper 2, and knowing that it would be Cu plus or Cu plus 2 is a good idea. Also, the reverse of that, if you're given a formula that has copper in it, you want to be able to go, oh, wait a minute, that's transition metal. That's one of the ones that I need to know. It's got to be +1 or +2, and then you can figure it out from there. So I would also suggest making flashcards for those transition metals with variable charges. The next page of your handout, and as I have here, these are polyatomic ions, names with symbols. It's a pretty big list of different polyatomic ions. The ones that I have highlighted here, these are the ones that I want you to make note cards for and learn. So any of the ones that are highlighted here are free game for homework problems, quiz problems, test problems. Okay, so these you definitely want to make flashcards for. So for instance, on one side you put the NO3 minus 1, you put nitrate on the other side. Then we have NO2 minus 1, that's nitrite. So recognizing based on the formula what the name of it is, what the charge is for it, or from the name, knowing what the formula and charge are for those substances. Okay. Further down the list here, we have acetate, which is another one. It was on the previous slide. There is only one positive polyatomic ion, and that's called ammonium. It's NH4 plus 1. Make sure you make a flashcard for that one as well, because that one is also fair game. Now, we're just going to do a couple of quick examples of putting these things together. So, for instance, a classic that we've seen before, Na and Cl. Na is +1, Cl is -1. So those are the ions involved. We have sodium. Remember, the cation does not get a change to its name. It's just whatever the element is, but the anion does. It's called chloride, and so the name of NaCl is sodium chloride. Then we do another example, CaF2. That would be a calcium ion, and then we have the fluorine -1 ion. Ca is just calcium. The F-1 is fluoride, and so that would be calcium fluoride for the example there. We can also do the reverse and start with the name. And so let's do one of those. For instance, potassium oxide. Well, potassium, the symbol for potassium is K, and because potassium is in group 1, it has a +1 charge. Oxide, the root of that is oxygen, so we have an O for its symbol, and since it's in group 16, it has a -2 charge. And as we talked about the other day when we did the patterns, trying to figure out what the charges would be, we have to have enough positive charge to balance out negative charge and vice versa. So I've got a +1 here and a -2 on this side. I don't have enough positive charge, so I'm going to need another potassium. So 2 +1s, that would balance with my -2, and so the formula for potassium oxide is K2O. Notice when I wrote the formula, though, that I did not put in the charge of the ions. The charges don't show up in the chemical formula for the substance. Okay, it should be neutral. They're not there. It's just potassium oxide is K2O. So that's what we have. If we did another example, such as magnesium sulfide. Magnesium is Mg plus 2. Sulfide is S minus 2. So plus 2 minus 2, I just need one of each, and that's MgS. What if I had a polyatomic ion? Let's just do one of those here for a second. I'm going to keep the magnesium, but I'm going to call this magnesium nitrate. Well, according to your handout that you have, magnesium is the same, but nitrate is NO3 minus 1. I've got a positive 2 charge. I've got a negative 1 charge. That means I need more anions. And so now I've got plus 2 and 2 minus 1s. I'm good. Writing the formula, though, is a little bit different. Magnesium is fine. But now I need to show that I have 2 nitrate groups. And we've actually run into this in the past when we were doing finding the molar mass for substances. If we put it in a bracket and then a 2 on the outside, that tells me that I have 2 of what's in the bracket. So I have 2 nitrates, magnesium nitrate. Okay. Another rule, when writing the formulas, you must have equal amounts of positive and negative charge, which we just talked about. If you need more of one, you must add another cation or anion. So we did those examples. Let's just do one more just to show that, emphasize that again. We'll do something like, let's say, copper to nitrite this time. Copper 2, if I see that Roman numeral 2, that's telling me what the charge is on my copper, so it's Cu plus 2. Nitrite, nitrite is not nitrate. Nitrite is NO2 minus 1. Only 2 oxygens in the nitrite instead of 3 like the nitrate. But similar situation, I need more anions to balance out my plus 2 charge for the copper. And so now that I have that, there is my formula. Remember, you can't just change the subscripts of, in this case, the nitrite polyatomic ion. If you do that, it's a completely different substance. It's not what's being described. You put it in brackets, put a subscript on the outside of it. That's it. Good to go. So, I know that was really quick, but those are the examples that I have for you. Your assignment right now, though, is to worry about getting the flashcards made. So like I said, I highlighted the different polyatomic ions that I want you to work with. And make sure you make flashcards for all the polyatomic ions that are highlighted, such as these. And then make polyatomic ions for these transition metals. These are ones that you should definitely recognize. Be careful when you're making the ones for mercury 1, mercury 2. It's Hg2 plus and Hg plus 2 is the difference between mercury 1 and 2. And then make sure you make flashcards for those 3 transition metals that have fixed charges. Okay, sorry to stop there for a second when I got interrupted by something. So that's it. Make those flashcards for Monday. Don't just make them, but give them a run through a couple of times, okay? By the end of next week, we are going to be taking our first quiz on naming ionic compounds. I mean, I know flashcards aren't the most fun thing to do, but honestly, when you get to class at the start of class each day, if you run through them once or twice, you know, at night, 5 minutes, go through them a couple times, you know, the ones that you really know, take them out, focus on the ones that you don't, then run through them again. Really, if you take 5-10 minutes, you know, depending on how much you're struggling to review those, they really do help. Like I said, the only reason why I have students make these flashcards is because past students have said that they really help in reviewing. So make them, have them ready to go. I want to see them Monday morning. Make sure you keep the handouts that you got today for the naming. Make sure you've got some of the examples down because we're going to be practicing naming on Monday. So there you go. Good luck. Get a marker, get your note cards, whatever you need to make your flashcards, and get them made. See you Monday.